in this ionic product of water, we can say experimentally concentration of H3O plus is equal to 1 into 10 raised to minus 7 molar. It is found experimentally that concentration of H3O plus at 298 Kelvin is 1 into 10 raised to minus 7 molar. And we formulated the reaction. This reaction Kw is equal to H3O plus into OH minus. Kw is equal to H3O plus into OH minus. It is obtained from the first step. H2O plus H2O reversibly gives H3O plus OH minus. So when we take H2O, equal number of H3O plus and OH minus will be formed. How many H3O formed, that much OH minus also will be formed. So we can say concentration of OH minus also will be equal to 1 into 10 raised to minus 7 molar, because number of H3O plus will be equal to number of OH minus. So we can say if concentration of H3O plus is 1 into 10 raised to minus 7 molar, concentration of OH minus will be 1 into 10 raised to minus 7 molar. So we can write it mathematically as Kw is equal to 1 into 10 raised to minus 7 molar whole squared, or 1 into 10 raised to minus 14 molar square. Kw has a value 1 into 10 raised to minus 7 molar squared. 1 into 10 raised to minus 14 molar squared. So Kw has a value 1 into 10 raised to minus 14 molar squared. And this Kw is called ionic product of water. Ionic product of water is known as Kw. Then from the amount of H3O plus, how much H3O plus is there, or from the concentration of H3O plus, we can suggest the solution is acidic, neutral, or basic. Acidic, basic, or neutral, we can suggest. We know H3O plus is corresponding to the acidic character. H plus is acidic character, and the basic nature is from OH minus. So if the H3O plus value increases, we say it is acid, and if OH minus value increases, we say base, or H3O plus value decreases, we say base, or OH minus value decreases, we say acid. So from the amount of or concentration of H3O plus ion and OH minus ion, we say the solution is either acidic or basic. So if the H3O plus concentration is greater than OH minus concentration, the solution is acidic. And if H3O plus ion concentration is equal to OH minus concentration, it is called neutral. And if H3O plus ion concentration is less than OH minus ion concentration, we call it as basic. This is the classification: acid, base, or neutral. So for example, consider HCl is added to H2O. HCl is added to H2O. So what will be the nature of HCl? HCl will give H plus and Cl minus ion. So in H2 also we have H plus and OH minus ions according to ionic product of water. So the concentration of H plus ion will be increased. It is called common ion effect. And according to Le Chatelier's principle, the system will try to reduce the concentration of H plus ion. So for reducing the concentration of H plus ion, the system have to undergo the backward reaction. So the only way is H2O have to remove the H plus ions backward as H2O. For that, this H plus ion will be reacted with OH minus or combined with OH minus to become H2O, and the amount of OH minus thus will be reduced. I will repeat one more time. NHCl ionizes H plus ion and Cl minus ion will be formed in H2O. There is already H plus ions and OH minus ions, so the H plus ion concentration will be increased. According to Le Chatelier principle, the system will try to reduce the H plus ion concentration. For that, the extra H plus ion formed will combine with these OH minus ions to form H2O. So H2O will be formed. So the OH minus ion concentration will be decreased. OH minus ion concentration will be decreased. So H plus ion concentration will be increased. So it is acidic. As H plus ion concentration increased, it can be called as acid. In the case of NaOH, if we add NaOH to H2O, what happens? NaOH ionizes as Na plus and OH minus. H2O ionizes as H plus and OH minus. What happens? OH minus ion concentration increases. So according to Le Chatelier's principle, the system has to reduce the OH minus concentration. For that, this OH minus ions will combine with the H plus ion to form water back. So what happens? A OH minus ion concentration increases. So the solution is called basic in nature. In case of neutral, no change in H plus ion concentration or OH minus concentration, so it is neutral.